What's up, everybody? Welcome to my channel, Ochem University. Today, we're going to be going through this practice problem, a question of the day for organic chemistry, so feel free to give it a try. Let's go ahead and jump into it together. Alright, so here's our problem. We have an alkene group over there on the left-hand side of the screen, and we're reacting this with HgOAC subscript 2 with H2O. So, and our follow-up step is going to be with an NABH4. So how do we want to go about solving this problem? Well, first off, we definitely want to be able to analyze kind of what we have going on here. So first off, we got the alkane group here, and then our HgOAC H2O with the NABH4. So we're definitely dealing with alkene reactions, and we're looking at this mercury. So you want to know that we're dealing with oxymercuration, demercuration. The H2O tells you which functional group to add, so I definitely want to add an alcohol OH functional group, and I got that based from the H2O. And then the NABH4 is going to be our follow-up step. That's the thing we're going to do last. It's just going to kind of help clean everything up. But of course, recognizing that this is oxymercuration, demercuration, you want to differentiate whether we're dealing with a Markovnikov or a anti-Markovnikov. So go ahead and think about that and give it a try. All right, so I'm going to go ahead and walk through it. So with HgOAC, we have the Hg, and it's connected with two OACs. Now, OAC is just a fancy way of saying acetyl group, right? So my AC is a C double bond O with a CH3, and this is connected to the O. Same thing on the other side, it's an OAC, so we have two of those connected to Hg. Hg, interestingly, also has a lone pair, and the reason why that's important is because with my lone pair, I know that it has the potential to not only get attacked, but also the ability to attack because of the lone pair that we have. So as the alkene reaches out and hits the mercury, we're also going to have the lone pair reach out and go hit the other side of the adjacent carbon. And why do you think that might be important? Well, because we want to prevent a rearrangement event. Now, granted, for this problem, we're not going to have any type of rearrangement, and even if it was a different problem, anytime you're dealing with an alkene and HgOAC, oxymercuration, demercuration, we're definitely not concerned for any type of rearrangement event to happen. If this was a different alkene problem, then of course we potentially could have a rearrangement, but that's one of the benefits here of doing our oxymercuration, demercuration, is we're going to prevent the formation of a carbocation, thus preventing the formation of any type of rearrangement. And it's because it's going to go through an epoxide mechanism, so it's going to form a triangle shape, and so then we're going to prevent any kind of carbocation from forming. So we kind of get to a point where we're in here, and we do have an epoxide, and that is going to be syn, so it's going to be on the same side. And as the Hg was attacked, and not only did the Hg's lone pair reach out and hit the alkene, the previously carbon there with the alkene, we're also going to kick out an OAC. So we only have one OAC now, and then the Hg is also going to be positively charged. So clearly we have one side that's going to be considered anti-mark and one side that's going to be considered mark. So we're going to take our water group, and our water group is going to go to the side of the more substitute, and that's going to bust open this. So when that happens, I'll just write it over here on the right hand side of the screen. You can see that all the carbon chains are the same, so nothing changes here. And then my Hg is up here with its OAC. And then my new OH group comes into town, and that's going to be located right there. So you can see we're getting pretty close to where we want our answer to be. The NABH4 is going to help solve the day so that the boron's hydrogens here, one of them can cleave off from the boron. NABH4, one of the hydrogens can reach out and hit this carbon, kick out the Hg, and actually kick out the OAC so that those are separate. And so what we're left with is a shape that looks like this, and that's going to be our letter A. So here OH, so that's Markovnikov, more substituted. Here our best answer is letter A. So thanks for tuning in. We will definitely do more problems like this, so stick around, and we'll see you next time. Oh, and by the way, be sure to check out OchemUniversity.com. OchemUniversity.com, you'll get access to plenty of practice problems. You'll get all kinds of resources. I have a video archive and all types of video problems and explanations just like this that walks through every mechanism, every reaction that you need in organic chemistry. So definitely check it out. We'll see you then.